In this video, I'm going to talk about scientific notation. And things you will learn from this video include how to change a number into scientific notation, how to multiply scientific numbers, how to divide scientific numbers, and an example ACT problem involving scientific notation. Don't forget to hit that subscribe button. So what is scientific notation? Scientific notation is a shorthand way of writing very large numbers or very small numbers. So here I got 10 million, 300,000, and 39 hundred thousandths. Now if I were to repeatedly write these over on a piece of paper, I'm writing a whole bunch of zeros in both of these numbers. So scientific notation makes it a shorthand way to write these. So in order to convert these to scientific notation, I'm going to take this first number. I'm going to find the first non-zero digit from the left. In this case, it's going to be the 1. I'm going to write that number, then a decimal point. And then I'm going to move to the right until I hit my last significant digit, which would be a non-zero number. In this case, it would be the 3. The zeros behind it are insignificant. So I'm going to bring down the 0 and the 3. Then I'm going to write times 10. Now 10 is going to have an exponent. That's going to be the number of times I move the decimal point. So right now the decimal point is at the end here. And we currently moved it right behind the 1, so I got to count how many times it moved. So 1, 2, 3, 4, 5, 6, 7. So it moves 7 times to get to the right side of the 1. So my exponent is going to be 7. So 10,300,000 in scientific notation is 1.03 times 10 to the 7th power. Now if I got a number less than 1, I kind of do the same thing. I want to move it from the left going to the right. The first non-zero number, which is going to be the 3, and then a decimal point, and after that just one number, and that's a non-zero number, so I'm going to include that. If it was 0, I would actually put, you could either have 3 or 3.0 if it was 0, but here we have 3.9, and I'm going to do times 10. Now I need to see how many times the decimal place moved. So right now it's right here, and we moved it to right past the right side of the 3. So we moved it 1, 2, 3, 4, 5 times. Now when you're dealing with a number less than 1, the exponent is going to be negative. So we're going to have negative 5 here. Alright, so that's how you change a very large number to scientific notation and a very small number to scientific notation. The number greater than 1 is going to have a positive exponent on the 10. A number less than 1 is going to have a negative exponent on the 10. Now when you multiply scientific notation, multiply two numbers that are in scientific notation form, what we first want to do is multiply the numbers 2.0 times 3.0. That's going to give you 6.0. And then you want to look at the exponents on the 10s. You got 10 to the 9th power, 10 to the 4th power. You're going to add the exponents. So it's going to be times 10 to the 13th power. Okay, so you multiply the numbers together, and then you add the exponents on the 10 together. Now if it came out to like 60.0 times 10 to the 13th, I still want to have it where I only have one number at the left of the decimal point. So 6.0. Okay, if I did that, I would need to change my exponent to 14. So I had to move it over one more spot. So another times another 10. And you remember exponent is 10 to 14. That's just 14 zeros after that. Now when you divide the two numbers, 4.0 divided by 2.0 is going to give you 2.0. And then with the exponents on the 10, instead of adding them, you're going to subtract them. So 12 minus 9 is going to give you 3. So times 10 to the third power. So 2.0 times 10 to the third power. So when you're dividing scientific notation, you need to divide the exponents. So here's our example problem. A certain computer can perform 1.5 times 10 to the 8 calculations per second. How many seconds will it take for this computer to perform 6.0 times 10 to the 16th calculations? All right, so for this problem, I can set up a proportion. So I know I can perform 1.5 times 10 to the 8 calculations per 1 second. This will be proportional to 6.0 times 10 to the 16th calculations per some unknown X amount of seconds. Okay, so it's going to be proportional. So what I can do here is do the cross multiply. So 1 second times 6.0. So 1 times 6.0 times 10 to 16 equals 1.5 times 10 to the 8th times x. And to get x by itself, I need to divide by 1.5 times 10 to the 8th power. So you do that to both sides. And we saw from our example, when you divide the number 6.0 divided by 1.5. That's going to be 4. And then for the exponent on the 10, you need to subtract the exponent. So 16 minus 8 will give you 8. All right, so it's going to take 4 times 10 to the 8th seconds to perform 6.0 times 10 to the 16th power calculations.